Hi, hello everyone. My name is Michel Roy from Ottawa, Canada, and today I'll be doing a detailed walk around of my BearHawk 4 place. So stay tuned. Background. So this plane started as a quick build. I did not buy it directly from the factory, so I bought it from a guy in the state. His name is Bill, and so I was in 2013, October 2013. And I did the first flight last November 2018, so it took me, well, 5 years part-time. And so what about the number of hours it took me to put it together? So it took 2,800 hours of time to complete this quick build. So obviously it's well above average in terms of times. But that includes everything, obviously putting together, but also the painting was done also by me, which took quite a bit of time, as well as all the interior, the upholstery was completed by me as well. So that's a lot of time. In terms of the painting system, and the finishing, so I use the AirTech system. So AirTech is basically the glue is a bit different than others. It's a urethane-based glue, I believe, and it's diluted with acetone. So I don't have much experience in fabric systems, so I can't compare with others, but that's what it is. And the finishing system is actually the painting is actually the Endura system. Endura is a factory in Alberta, Canada, and actually they've developed, well, it's an industrial based painting system, but they have also paint for the aviation part of it, and especially for fabric as well. So the paint system was developed for fabric application as well. It's much cheaper than other system, and so that's why I use that finishing system. All right, so engine part. So this is well, we'll see the detail later on. I'll be removing the cowling, but behind this there's an 0540 engine. Was rebuilt, so it's fairly new engine. The prop is a Kato prop. It's a fixed pitch propeller prop. And I know that a lot of people say, well, why did you actually use a fixed pitch prop on this engine? Well, actually, well, first of all, it's much lighter than a constant speed prop, but also in terms of maintenance, there's no maintenance to it, right? And it's much cheaper. And actually, talking to Craig at Kato Propeller, he did design the prop specifically for my application, and so far after 40 hours I'm pretty satisfied with the prop. I can run the engine in cruise full forward, meaning that all the throttle up, and basically I'm just below the red line, so was fairly well designed in my opinion. Yeah, that's what it is. One feature about the cowling system, well, first of all, the air intake. So as you could see, it's very different than regular BearHawk. So I did use, and some people already recognize that the air intake is based on the RV. And actually, the scoop is actually an RV6 or RV7 scoop. And so that took me a bit of time to actually figure out how to install this, but I think it gives a pretty nice, cool finish. So yeah, back to the cowling system. So the cowling doors, you don't see, there's no fastener to attach the top cowling doors to the bottom cowling. So again, been using a lot of features from the RVs. So the cowling doors are secured in place with a piano hinge, and the hinge is actually removed to open the cowling door from the inside. So I'll show some of a detail of that later. So now, pretty nice finish. No external fasteners. Back to the cowling. So it's secured in place with screws, and as you could see on this plane, so I'm using a lot of these. I think these are called Tinnerman countersunk washers. That's basically to protect the paint. All right. Okay, now looking at the windshield, very standard here. The only difference is that the intersection fairing is fiberglass. So again, I've used the same approach as the RVs, which is to lay up the fiberglass directly on the windshield. So it's basically secure to the windshield at this point in time, right? And the way that this windshield is secured down is with these screws on the top side, and screws on along this upper, I guess upper lantern, if I should say. Okay. So on the landing gear side, pretty standard here. The thing about the fairings, so I didn't use any fabrics to fair the landing gear. Sorry. So it's basically aluminum base. So it's a sheet of 25,000 aluminum, which is wrapped around, and it actually gives a pretty nice finish. So these screws, actually there's a trailing edge fairing here on along that edge, and then here as well. So all this is secured. If you remove these screws, actually this is the small tubings where the fabric was wrapping around. So the screws doesn't go through the structure of the landing gear, but it's going through the small tubings on the trailing edge. So it's nice finish. Looking on the bottom side, I guess a bit of a oil on the belly, which is normal business. So those fairings, this fairing is basically from Bob Barrow's. Pretty nice actually. It fit right on. So that's the one. So this one, actually I had to roll my own fairing. Took a bit of a time, like anything here, but I believe it did a nice job here. Right, so let's move down the wing side. This is a nice fairing as well from Bob Barrow. P2 tube is Van's Aircraft, pretty cheap P2 tube. And this guy here is actually an angle of attack probe for my LRI system. Landing light, fairings on that side. So let me just go underneath here. Alright, so I guess not much to see on that front. So the skylight, this is the skylight design that I came up with. So it's basically six windows, and it gives a pretty nice view from inside. I really like the skylight system, that's for sure. The fairing, so this is intersection fairing between the wing and the fuselage. Nice and clean. Okay, so let's look at the door system. So someone may have already noticed that my door is different than the regular system. So this is a seaplane door or a gull-wing door. So let me just open this. There we go. Works pretty nicely, so I really love that that type of a door instead of the regular one. Again, that's personal opinion, but eventually this plane will go on float, so the attachment, the rear float attachment is already there. So that's the next project for me. Not sure it's very visible from here. All right, let's move this. Okay. So there's two latching mechanism to latch the door down. So that's the lateral one where it's actually push pins that engage in the fuselage part of it, and the same thing on that side as well. And I've got the regular latch system that basically latch on the bottom here. So if I just move this down, this latch. Okay. Just to show you how this door is works or secure in place. So this is two aluminum piano hinged, and the bottom portion is riveted to the square steel tubing, and the top portion is riveted to a U-shaped aluminum channel. So these two bolts, those bolts are not going through the fuselage structure. These bolts are going through the aluminum channel, and this is only to control where the channel is located. Okay, let me just open this up here. So what I'm trying to say, okay, this is a channel that I'm talking about here. So that channel clamps basically around the bottom tubing here, and it's basically held in place, secured in place, or compressed in place by these two bolts here, and two bolts in the front. And that bolt I was talking about on the outside, this is a bit of an adjustment bolt, because this thing doesn't perfectly line up with the tubing. You have to push it a bit back in the adjustment of the door. So this is used to basically push in or push out the tubing. All right. So now moving on the interior portion of it. So this is my seats. I did the upholstering myself, so that's a bit of a project. Took me about 2 months to come up with those nice seats. So I'm using on the bottom cushion, I'm using the Comfort foam. That's pretty heavy foam, and on the back side is a regular high density foam. That's on the front as well as on the back bench. Okay, looking at the dashboard, in terms of avionics, that's pretty simple. So I went with the GRT Sport IFIS system, and also I've got the EIS. So the EIS drives all the engine data to the Sport IFIS, so that's a pretty nice system. In terms of the layout, that's fairly standard. So this is actually my angle of attack indicator, which I actually put right above the airspeed, and it's kind of a, well, while you're landing, it's very well visible, and I actually really like this this angle of attack system. Okay. So there's a bit of light reflection on the firewall, but I guess you'll get a sense of it. So that little valve here, that's the temperature control for the cabin. So this is the heat from the heat exchanger coming in there, and that's a deflector. That's why it is. On the braking system, so the fluid reservoir is up here. It feeds the through these clear tubing. It feeds the low pressure oil to the co-pilot cylinders on the low pressure side. Then goes through the high pressure side all the way up down to the low pressure side of the pilot side, and then the very bottom tubing goes up to the parking brake valve. So a view from the underside of the panel, from the side. So all the cabling, the control, the throttle mixture and all that, so there's a sub panel here attached to the main panel, and I've got these 1-2 cross member basically to secure that sub panel in place. So that's that. Alright, I just peeled the carpet to so that we have access to the fuel line going through the floor here. So first fuel line coming from the top, and the one coming from the side, they connect to a T. So the T here is different than what's being shown in the plan or in the manual, in the sense that actually the end of the T is facing forward. So I have this loop that goes to the front and then back, and basically the fuel, there's another band here and it goes under the floor. The reason why I did that is initially when I plumbed that T, so that point this way, I had a really hard time to make that that band going through to the floor here. So I believe by doing this way it's much easier to install, and you don't have that fuel line that could actually, because initially it was probably around here, so that fuel line is not in a way having your feet here, and so you don't want to actually touch that fuel line anytime, right? So that's how I did it anyhow. I guess you see a bit of what's going on behind the panel. Lots of wiring. When you start wiring this, you think that there's not much, but at the end of the day it's kind of very well involved. So I could actually show you, not sure if it's visible. Yeah. So you can see the how my system works. So this is all the my fuse blocks. So there's 2 fuse blocks. Again, it's a fairly simple system, but I didn't use any breaker. It's all about using these little fuses. They work pretty nice. This is the valve, fuel valve. It's yeah, this valve is a Newton valve. Okay. So in terms of the control here that I have, so that's carb heat, throttle mixture, that's a parking brake. This here is to control the oil temperatures. Alright, I guess that's pretty much it. View the skylight. Looking at some of the finishing touch. So this is a nice cover that covered the front side of the upper, I guess the vertical longeron, if I should call this. So all my wires is going through that. The fuel, so you see actually the fuel tubing here. Actually this rubber hose is not, it's only protection that goes around the aluminum tubings for chafing, to minimize chafing problem around that portion. Alright. Okay, so let's finish the walk around here. So that's This might come antenna, the static probe. So this is the front cover and the back cover access to the tail section. Yes, that's pretty standard. Flying wires. So this is the levelers are pretty well balanced. So I like that. On the rudder portion, someone will notice this little thing here. So actually this is my trim tab. It's based on, they call this a gurney flaps. You can Google that. And basically what it does is that the little protrusion makes a high pressure on that side, so it tends to push, for instance, it tends to push the rudder this way. So it's a very, very effective way, and it's been used also on the RV side. So the good thing about that is that you don't have this like regular trim tab that basically change the profile of your rudder. So viewed from 5 feet, you never notice that there's a trim, right? So that's a nice thing to try. Actually, it's very, very easy to try and put in place. So it's a channel, not a channel, but a piece of 25,000 aluminum sheet bent. And initially, I just secured it in place with some tape. And once I found the exact size that I need to trim this rudder, then I just rivet it in place, and that's it. Okay. So I guess that's the same thing that we've discussed. So the cargo doors, pretty standard. This is my way of actually securing the door to the wings. So it's a little aluminum strap, and pretty simple to put in place. Okay, so on the cargo aspect of it, there's pretty much per plan. Didn't change much things. It's a bench, the back bench, with the shoulder harness, which are secured on the upper tubing that you see in the back here. Okay. Now moving on to this side, very similar feature that I've just described for the rudder. So again, this is my not trim tab, but the aileron tab, because I had a bit of a heavy wing, left heavy wing. So same principle here. So basically this tab is pushing this aileron up, which basically push this wing down, which control my left heavy wing. Again, very easy to install, to put in place, and it's very effective. And by the way, you could again Google that. The NASA has done extensive analysis on these gurney flaps, and basically the way it works is that not it works, but the height of that flap has to be about, I think, between 2 to 3% of the chord of what you're trying to control. Okay, going around. So I guess we're back to the Cowling. So what I'll do, I'll uncall the engine and I'll show you a bit of a detail of what's under the hood. Okay, let's now open the coiling doors. As explained a bit before, so the hinge pin that goes through the piano hinge is this pin here. So when I pull this, basically I'm unlatching the cowling from inside. Okay, so that's how this thing works. There we go. Sorry, let me just touch this here. There we go. So this is the piano hinge that I was explaining. So the pin from the inside basically secure the bottom hinge to the top one. So it makes the whole cowling probably much rigid overall, because it's firmly held in place with that pin. Okay, so this is the overall view of the engine 0540, as I explained before. The baffling is from the RV10 kit, and actually I did use a lot of component from Van's aircraft, and specifically for the RV10. And by the way, there's a set of plan available on the web, and I'll copy and paste the exact address. But those plans is for the firewall forward of the RV10. So that's very valuable piece of information. Obviously you cannot use this as is, but it's spelled out in those plans. It's spelled out every single components that have to be used for the installation. And basically I went through these plans, and I more or less follow the approach of for the installation of all the components and all that. So I think you should also look at that. The oil cooler is mounted on the firewall, and this is the 4-inch scat tube that goes through that 45 angles, I guess, diverter through the oil cooler. And this is the valve I was talking about here. So this valve basically controls the amount of air going in the oil cooler, through the oil cooler. Sorry. Okay, so the next step will be to remove all this and have a full access to the engine portion of it. Okay, so let's now remove the cowling. That was the last one. Okay. So at that point, I just drop the portion. There we go. That's the bottom section. And the top section. Easier to see. Do a quick overview of the engine installation. Starting from the top, so we see the baffling that goes all around. I mean the rubber baffling that goes all around the aluminum baffling system to create this tight sealing system. That's on the left side of the engine. So as I said before, got the oil cooler. So if I move on the right side, that's what we actually see. Okay, so let's start talking about some of the detail of this. So the exhaust system, that's the Vetterman system. Pretty nice system. It fit right in place. Didn't have to modify anything. Clearance wise, with the cowling, I've got about probably 3/4 of an inch as a minimum with the cowling. So that's pretty good. So that's that. This is the I guess the heat exchanger. So this is for the cabin heat. So the air is being supplied from the top side, goes through the heat exchanger and through up to the valve here on the firewall, which is controlled from the inside. The battery. This is a PC680 battery. It's mounted sideways, and so I've actually spent quite a bit of time but try to figure out all the things that goes on the firewall, and I came up with this solution. So basically the battery can be easily removed. So you just have to slide the battery this way and you drop it down and it goes down. So that works pretty good. Okay, moving to the front side, we see the alternator here. So that's a car alternator. I don't exactly have the brand, but it's an internally regulated alternator. It's actually the same if you go on the Vans Aircraft forums. A lot of people is using this type of alternator. It goes pretty well. The only thing that I did is to actually install a larger diameter pulley so that the alternator runs at a lower RPM. So the B-leads runs all the way up to this solenoid here, and the reason why I have this solenoid installed is to basically, because with an internally regulated alternator you cannot shut it down with I do have a switch to control the alternator, but the only to shut it down completely offline is through this solenoid. So with this I have the ability, if something goes wrong, is if I've got high voltage spiking up, I can actually turn off the alternator using the solenoid here, which is obviously is connected through to a switch on my inside the cockpit. Okay, there's two more solenoid here. So the first one here, that's the battery solenoid. That's control the battery input to the my fuse block, and this little guy here beside it, that's the starter solenoid. So all these ones are connected together through using these copper bars. And again, that's pretty standard way that the RV guys are doing it. I mean, all this interconnection with these copper bars. Okay. So this is the ANL fuse. So that comes from the alternator, and then it goes through this solenoid and eventually to the fuse block inside. So this is a 60 amp NL fuse. This little donut here, that's basically the amp meter. So the amp meter is basically telling me how much current is flowing in or flowing out from the alternator through my system. Okay, regular magnetos. So those are two Bendix magnetos, pretty standard from that part of it. Okay, moving on this side here, so this hose connection, so that's for the manifold pressure hoses that goes inside into a transducer. So that's that. Okay, looking at the carburetor portion of it. So this is a fab box. So fab, it's an RV component. Fab stands for the filtered air box. So what you have inside that box is a novel type of filter. Again, I did not design this. It's pretty much standard from RVs. So this scat tubing coming from the top, so that's the carbide system. So basically it's a flap actuated here from the inside, and there's a bypass as well. So that carbide takes the heat from this other heat exchanger, and the air from the outside comes from this side. So it goes from here, heat exchanger, and then to the intake of the filtered air box. Okay, so what I want to show here, a bit of all the control system that goes through the carburetor. Again, all the cables are basically from Van's aircraft as well, and all the little component to secure the cables is all from Van's aircraft as well. Right, looking from that side, alternator, starter, and everything is well secured to the engine compartment. So what do we have on this side here? Oil cooler, which is mounted on the far wall, as I explained before, and this is to control the amount of air going inside the oil cooler, so that I can control the temperature pretty well with this device here. So basically it's a butterfly that close or open or improve or decrease the amount of air going through the oil cooler. In the background here, you could see the engine fuel pump. So I didn't discuss this, but basically I do have an engine fuel pump as well as an electrical backup pump, which is located under the seats. So basically it's three systems. It acts with, the gravity is one, the mechanical fuel pump second one is and the electrical backup pump is the third system. Okay, now just above, so this little box here is a slick start. So that's called a magneto start booster. So I installed this to help, especially in the winter, the starting. So that's that. This little gizmo here is basically where the fuel transducer and the oil transducer is attached to. So this is from Van's aircraft as well, with the fuel tubing that goes to the carburetor. So it sends the fuel pressure, and the oil pressure goes to the pickup and the oil pressure on that side, yeah. The breather tube that goes all the way down. Okay, so that's the breather tube. It's got this way because initially I had quite a bit of oil, I guess, coming out from the breather tube until I cut it this way, so I guess it kind of pressurized the tube instead of sucking air out of the engine. So at this point in time I've got less, well, I'm losing less oil from the breather tube. So this little thing here, so that's basically the my winter kit. So I'll be removing this, I guess, in a couple of weeks. Okay. On the fab box, so this is a filtered air box. So this is a bypass, I guess, door. So in the event that there's a blockage of the intake, so you could actually, this is basically an alternative air entrance that bypasses the filter. We can spend some time going through the cowling, the bottom cowling, with the installation of the intake scoop. So that's what it is. Mind you that there's a fair bit of work to come up with this final installation, as the air scoop, if you ordered it from Vans, it basically only the bottom portion is the same. Everything else has been cut off and redone. So the way it is, this is all aluminum skin, so there's a large opening through that, and I basically drop that air scoop from the inside. So let me show that to you. So this is the scoop. So basically the fiberglass goes all the way on top of this, and I've got this aluminum ring that runs above it. So basically it's riveted in place, and the fiberglass is sandwiched between that top ring and the outside. So that's how it's installed. So I've put this aluminum tape, and you can see that on this side there's a bit of I guess some heat effect. So that was to protect the paint, so I did that up front, so the paint didn't yellowish on the back side, which is good. So if we look at the side portion of the cowling, so that's how I did it, to basically add some stiffness to this whole system. And this is where the piano hinge here connect with the door. So this whole thing has been done this way. So the way, I guess that's pretty much it. Okay, now if we look at the upper cowling section, that's what it looks from the inside. Again, you can notice the same two channels where eventually the oil door, not the oil door, sorry, the cowling doors are secured to. You see the oil door in the center section, and up there, that's the ramp, the two ramps to So basically the baffling system eventually rests on these two sides here, left and right, to make a nice seal around the cowling entrance. Okay, so that's how this thing looks. Okay, so let's put the cowling back together. Let's see how long it takes to do it. So that's probably the most difficult part of it, is to actually put the bottom portion of it. It's a bit of gymnastic to make this happen as a one-man operation. So let's try to do it. Okay, what I want to show you is how the baffling is sealing against the upper cowling. So I'll just drop the camera inside and hopefully the rubber seal against the top cowling, so it makes a pretty nice tight upper section. Moving the camera, looking the front side of it, and same thing, you see that the rubber is actually sealing pretty well on the top side. Moving to the ramp area, so actually the seal. So that rubber seal is actually held in place with this little tab here, so air coming in doesn't doesn't push that flap up, so it's held in place. So if I move on that side now, so this is looking in. So those are the baffles I was talking about. I had a hard time to install the cowling because this has to go on top of the ramp here. Similar on that side, I do have a little tab here that hold in place the upper baffle, so the air again coming in doesn't have the tendency to flap this up. Okay. Same thing on that side. So you can see here the seal along the, I think that's a pretty nice view of the seal along the upper ramp. So I'm talking about this ramp here. So the reason why I'm showing that, because that's very important, I guess, to control your cylinder head temperature. So any small opening through your cowling system, that's inefficiency. Finish this up. So the pin is spring gauge, so just have to push it down. There we go, so it's engaged. So now I have to push the pin inside all the way in. Almost done. There we go. We're done. So the ring is nicely closed at that point. Okay, looking at the hinge pin from the inside. So this is the pin here that I just moved in place. So the pin, as you can see, goes through the firewall here. So once it's in place, I just secure that pin to this this portion here, and that's it. We're done. Final walk around. This is a Kodiak brand new machine. Quite impressive performance, that thing. Back to the BearHawk. So I hope you guys enjoy this video. If you have any questions, feel free to drop me an email or question on YouTube. Thank you.